Hello, Algebra 2 students. This is day 5 of Unit 10. We got rational exponents. So we just want to do a lot of practice here. So starting with the very first one, when we've got same bases and we are multiplying, the rule is keep the base, add the exponents. So for this first one, we're going to keep that base of c, and then we're adding the exponents 3/5 and 7/5. And this one's so pretty to start because we have a common denominator, which is what we need to add. And so we're just adding those numerators together. So 3 plus 7 will give us 10/5. And then if you can simplify it, perfect. So that'll just give us c squared. Done. But I want you to keep in mind the idea that you keep the base as long as it's the same base, and we simply just add the exponents. Because when we go to look at the next example, and we have 25 to the 3/5 power, and then plus 25 to the 7/5 power, same idea, same base, so keep the base, add the exponents. Right now, we know what the exponent sum will be because we just did it a second ago, but sometimes it helps to see it in terms of when it's a variable versus if it's an actual number value. So we'd get 25 to the second power. And then because we can actually evaluate it, go ahead and do it. So 25 squared, that'll be 625. So what we don't want to do, we don't want to multiply the bases together and add the exponents together. That would be weirdly redundant. So keep the base, add the exponents. All right, this next one, we're not multiplying, we're raising to a power. So remember, in this case, as long as everything inside is multiplied, we can distribute that exponent. So 4 is going to get cubed, x gets cubed, y gets cubed. And then clean up what we can. So 4 cubed, you can do it on the calculator. So I could come over here and do 4 raised to the third power. But remember where that's coming from. Ooh, we got a lot of glare there. It's 4 times 4 times 4. So that's me 64 x cubed y cubed. All right, slide on down to the next line. Even though the base is numerical, remind yourself, keep the base. The only difference here is since we're dividing, we'll subtract the exponents. Right? So if we keep the base and subtract the exponents. All right, fractional exponents are a little weird to begin with, so let's just do one thing at a time. If I keep the base, it'll stay 8. If I subtract the exponents, I get 1/3 minus 2/3. All right, so if I do it like that, that's going to give me 8 to the negative 1/3 power, right? Negative exponent means to make it positive, because I kind of skip the directions, but if you actually come back here and skim them, write the answers with positive exponents. That's pretty much the only detail that we have to adhere to here. That means I'm going to flip this whole thing over and move it to the bottom of the fraction. So I would have a 1 up top, and then it would be 8 now to the positive 1/3 power. Right? And if I'm taking it and raising it to the 1/3 power, that is the same thing as taking 8 to the first power and then the cube root. So the cube root of 8 is just plain old 2. There we go. That big old thing just turns into 1/2. Because it's numerical, you can check that on the calculator too, if you're feeling like it. All right, otherwise, the next one, we've got all of this raised to the 2/3 power. So first thing, distribute the exponent and distribute it to everything. So 27 will get raised to the 2/3 power. And then this x to the 3/4 is also going to get raised to the 2/3 power. So 27 to the 2/3. You can pick up a calculator, but what this actually means, top number is your power, bottom number is your root. So we could square it and then cube root it, or what would be simpler would be to take the cube root, which would be 3, and then square it. That'll give me 9. So without my calculator, I can evaluate that. All right, over here, power raised to a power. So 3/4 times 2/3. You can multiply the exponents together and then simplify. So 3 times 2 is 6. 4 times 3, because remember, numerators together, denominators together, which would give me 6/12, and that can reduce right on down to x to the 1/2 power. So multiply that last result together. So it would be 9x to the 1/2, just like that. Now, could you write that with a radical? Sure, because the 1/2 power is the same as a square root. So you could write it as 9 and then square root of x. Right? Because it says positive exponent, I wouldn't go further than that, but it's good to notice those are the same. All right, let's try another one. Same thing. All of this raised to the 8/3 power. So I have x to the 5/2, and now if it's raised to the 8/3, that means times 8/3, and then y to the 4/11 raised to that power means times the 8/3 as well. All right, it's a little funky, but let's try it. So 5 times 8 would be 40. 2 times 3, we get 6. And then you can divide in math frac, or we could look at it as I can divide 2 out of both of those or whatever. If I divide both by 2, I get 20 and then 3, so x to the 20/3. Over here, same idea. If I multiply the numerators together, I will get a 32. Denominators together, I get 33. Can't simplify that, so you're just stuck with y to the 32 over 33. Not all the answers are necessarily the loveliest thing to look at, but it's still the answer. All right. Hopefully so far you're feeling kind of good. So let's do one more together, and maybe we'll save one of those to do in class. So let's do the first one. Let's do this guy over here. So because we have an exponent on the outside, I would take care of that first. Right? So when I think PEMDAS, exponents. So 6 is going to get squared, and then x to the 1/3, we're going to square that. So it means I'm multiplying it by 2 because power raised to a power. And then I'm just going to copy this down for the moment. All right, 6 squared, we get 36. Power raised to a power, when I multiply these, this is just going to be x to the 2/3, and then bring this guy along for the ride. Right? The only stuff we can do is we can combine those x's. So since we're dividing, you're going to subtract your exponents here. So when we subtract the exponents, we would get 36, and then x to the 2/3 minus 5/3. Still all over y. I probably could have shown some of this work off to the side. Sorry. 2/3 minus 5/3, oh my goodness, gives me -3/3, which is the same as -1, which means I'm going to take that guy and drop it into the bottom. So final answer there, 36, and then over x times y. I like that one. That's a little funky. It's fun to do. All right, we'll save this one for class. And then let's take a look at the ones on the back. We're going the opposite direction. So on the back, it's saying simplify the radical using exponent properties. It should say properties. Leave answers in simplest radical form or with rational exponents. So we're going to play around with that a little bit. We'll do a little bit of both kind of here. So first things first is if we are writing something, I'm going to write it like this. To the m power, and you're taking the nth root, keep in mind that's the same as I can write it as m in the numerator, n in the denominator. Right? So we can rewrite that. This is the equivalence right here. All right, so let's actually try it on out. So for the first part, we're going to take and rewrite it first so that this first piece would be x to the, there's a little 1 right there, and then 4 is your root there. So we can make it x to the 1/4. This part, when we rewrite it, again, you have a little 1 there. So we can make it x to the 1/3. And now that we have the same base and we're multiplying, we can just add the exponents. So we can make it x to the 1/4 plus 1/3. Now, if you don't feel like thinking too hard, grab your calculator, add it, and math frac it. Otherwise, remember that you guys are rock stars, so give this a try. 1/4 and 1/3. Your common denominator would be 12 because that's what they both divide into. So this would be the same as 3/12. This guy would be the same as 4/12 because I would multiply top and bottom by 3, top and bottom by 4. So that would give me x to the 7/12 is my answer there. Whew, look at how that last unit comes in handy. Okay, I like this next one. We got a little challenge going on here. So now we have the fourth root of 25 and then times the third root of 5. If you can't actually take those and get nice numbers, then we want to use the rules that we've been learning here. So what I mean by that, let's rewrite it first, rewrite it first. So it's not really any different than the last one because it would be 25 raised to the 1/4 and then times 5 raised to the 1/3. So the rewrite is identical. The evaluating is different. Last time I had the same base, so I could just add the exponents. If you don't have the same base, we need to get the same base. And so 5 and 25 are on purpose because we can rewrite 25 as 5 squared. So we're going to do a little substitution here. So in place of this 25 right here, we're going to plug in 5 squared because those are equivalent. So I'm not changing it. I'm just writing it in a different way. All right. That is being raised to the 1/4. And then it's still times 5 to this 1/3. Now let's clean this up. Power raised to a power, I can multiply. So if I do 5 to the 2 times 1/4, that's the same as 2/4 or 1/2. And then 5 to the 1/3. Now they have the same base. So we just add the exponents. All right. 1/2 plus 1/3. Again, if you want to, so maybe this time we'll grab our calculator. You can go 1/2 plus 1/3, get an answer, and then just math frac it. So that would be 5/6 right there in case you can't see it. So 5 to the 5/6 power. That's it. All right, now when it says leave the answers in simplest radical form or with rational exponents, if let's say it was multiple choice or I don't know, the direction said only leave it in radical form, you can flip this then back and write it as 5 to the 5th power and take the 6th root. Right? So this is equivalent to that. So maybe I can say or that guy. All right, so we're kind of practicing playing back and forth. All right. This one, we're going to save it for class because it's very similar to this. So I want you to have a chance to try one on your own when we're together. As for the ones that are left, just looking at a few more and then we'll call it quits here. So for this, because we have part of it in radical form, part of it with fractional exponents, my suggestion is let's rewrite everything with fractional exponents. We kind of need to get it all in the same format or kind of looking the same way to be able to take it from there. Right? So the numerator, y to the 18th and then the 5th root, you're going to make that y to the 18 over 5 divided by, all right, power raised to a power. We're going to multiply. So 24 times 2, that's going to give me y to the 48. And then remember, 24 is just over 1. So 1 times 5, that'll just stay a 5. Now that we have the top and the bottom with just one single fractional exponent, we're simply dividing. So when you're dividing, keep the base, subtract the exponents. So we're going to have 18 fifths minus 48 fifths. So it's a little clunky, but we have a common denominator. So 18 minus 48, that's just going to give us negative 30 over 5. All right, well, negative 30 over 5, we can simplify. That would be y to the negative 6th power. And then all we want to do is write that with a nice positive exponent. So take the reciprocal. So y moves to the bottom, and now it would be to the positive 6th power. Perfection. All right. For the ones that are remaining, this one is definitely a little crazy. Let's talk about that guy in class. Let's do one last one together. So down onto the bottom, in terms of what we have left going on here, I think what might be a good idea, kind of peek in. Let me see. Let's do the first one, right? But let's change the challenge a little bit. If we write it in simplest radical form, so we're not going to change it to the rational exponents. Let's try to keep it as a radical. So let's make the final answer in simplest radical form. What that really means is I'm going to break this up into a perfect fourth root times my leftover, if you will. All right. Perfect fourths. Geez, so you got to think, what perfect fourth goes into 32? Since 32 isn't that big, 16 is going to be it, because 16 is 2 to the fourth power. So it'd be 16 over here. 16 times 2 will give me 32. Right? In terms of exponents, to be a perfect fourth, you need to be a multiple of 4. Right? So anything on the inside needs to be a multiple of 4. So x to the 22nd, I can break into x to the 20th, and then I'd be left with a little x squared over here. Why did the 8th? 8 is a multiple of 4. That's a perfect fourth root, or however the heck you want to say it. All right, z. Holy moly. All right, if you can't tell, 145. Divide that by 4. All right, so let's see. That would give me y to the 36 once I take the square root of it. So I think 144. Yeah, there we go. So we can break it up into 144 and 1, because 144 divides nicely. So z to the 144, and then one single z left over there. All right, let's take the fourth root of each part. So remember, fourth root of 16, if you want to use your math, and then choice 5, and you can type in the fourth root of 16 just to confirm it. There's that 2 right there. Apologies if it's difficult with the glare. I'm actually in our classroom right now. So that comes out to be 2. Everything else, you're just going to take power divided by the root. So 20 divided by 4, that's going to give me x to the 5th. And then this one, power over root, y squared. This one, power over root. I did that one a moment ago. That came out to be 36. And then you're stuck with all this stuff underneath a fourth root. So 2x squared z to the first, or just z. Ugh. Not the prettiest thing, but that would be the answer in simplest radical form. Okay, we left 3 to do as some classwork. Oh, I take it back, 4, because there's one left on the front. All right, thanks for watching, guys.